Hello, is this working? Check, check. Sure enough, there it is. Awesome. Excellent, excellent. Welcome everybody to the stream today. Today's car is a 1990 Nissan 240. It has an RB20 in it. It's on a LinkG4x, which has the CAN Lambda and all that stuff. And I'm going to also enable. How is it just? Also going to enable CAN for a VTI gauge. So I'm actually going to look at that real quick right now. See if I have that protocol on this computer. I forget if I do or not. I may have to download it again if I don't have it. So CAN 2, let's have the link on it. So we're going to go to the second channel. And transmit user stream 1. We want more than 1 per second. We're going to go 20 times a second, which is pretty good. Then I have to go to my ID, which I need to get from it. I don't recall that it's the moment, but load stream, see if I have it on here. Nope, not this one. So cancel that. Cancel this. I'm gonna go check my email really quick. I have it on here. I actually emailed the revised version to BTI when we were working on this together. Where did it go? All right, downloaded it. Set up 1 second. Probably can't see the CAN controls. I don't have that window captured, so I'll just narrate a little bit. Right. It's kind of Italy or RB20, so just within range. Right on, Dustin. I know you live in Italy. I know you've been around, but I know Italy was one of them. All right. Need to fix those other cameras too. Just make sure everything's running right here. 1 times 175. That's good. Okay. Good there. All right. So let me go move these cameras really quick and get going. Try to see if I can get this to capture the dyno screen. That'd be a difference, wouldn't it? Just turn around again. Might work. See how that works. Yeah, that mess. Hey, dude. How's it going? Welcome, welcome. All right. So, like many Nissans, this one does not have good functioning idle control. So I got to fake a lot of it. I also don't think this thing has windows. No, so it's gonna be loud today. Uh, Now, when you don't have idle control, you have this issue of either you don't have enough air for it to run cold, or you have too much for it to run hot. And so one thing you can do is try and split the difference a little bit, but you still got to get enough air for it to run cold, unless the person's going to hold their foot on the throttle for a long time. So with this one, it's got enough air that it idles low, cold, but then it idles high, hot. And you can see right now we're at 1060 RPM, and the timing is about 5, somewhere in that range. And so that low timing reduces engine torque and allows it to idle down some. Now I can make it drop down more than 5 if I wanted to, but sometimes that makes it run a little warm. And this one right now doesn't have the fans on the computer. It has the fans on a switch, which we definitely want to change in the future because we want it to be on the computer. Last thing you want to do is rely on yourself to remember to turn them on, because that'd be bad. I never recommend that. And this ECU is powerful enough it can do way more than just the fans, right? So what do we do? Well, we'll go out of control here, and I got idle ignition control. And I have my minimum clamps -5. My target is 16. I can actually turn that down a smidge. Let me go with like a 14, probably. Hear the car idle, change note a smidge. Change note a smidge. I got 20 RPM out of it, so that's better than nothing. But that's good. So we're going to go down a little bit there. And then I'm going to demonstrate the rev hang. That's not so bad. When I go into gear, though, it can hang sometimes. Now, me lowering that timing helped it, and it looks like I might have worked with a snap on here. Let's see. Ignition. Corrections. 5B ignition. Oh, I already did it. So you can see here I did it at 0 TPS. It's pulling 30 degrees of timing up in these higher areas to drive the engine down. Now, if I don't do that, if this stays at 0, like this, and I rev it, so much longer it takes to come down. And in some cases, it'll just hang like for a long time. And we don't want that. We want it to um, drive itself back down to idle like it should, and not be unpleasant. Make sure it's always on. Always on. Okay. TBS. That's good. All right. So we're ready. So what I'm gonna do here is work on the volumetric efficiency map. I think Nissan throttle bodies were the go-to setup. Nissan throttle bodies don't have idle control on them. So I don't know. Maybe you're talking about like the new drive-by-wire ones, maybe. And this is an RB20, so it's a cable. It's a cable throttle. So any idle control is going to be via, a PWM or a three-wire system or a stepper even. I would never use stepper on a turbo car. I hate it. A lot of people do it, but I hate stepper on turbo. I definitely prefer a PWM system on a turbo car. All right, so I got the dyno in speed mode. You might not be able to see the mode in the picture there on the top left, but I'm going to control the speed at 35 miles an hour, and this will allow me to hit all the load cells I want to hit. All right, so 35 miles an hour in fourth gear is right here about 2,200 RPM. And my closed loop lambda is within 1%. So it looks like I already got that spot nailed when I did it on the floor. So there I was at like 2 pounds of boost, and it was pulling 7% fuel out, which I think got a little too much on the V curve. But at the same time, my target, for some reason, I probably didn't have rich enough because it looked like it was targeting 9.7 still. So I'm going to add a little more fuel to the target because I actually want to target a slightly richer AFR than that at 2 pounds of boost. So we're going to go to fuel. I'm going to go to my AFR lambda target table here. I'm going to look what I got here. So yeah, I still have it at 9.3 at the lower RPM. I'm going to add a little more because I think it should be a smidge richer than that. I mean, this is technically 7 pounds of boost right here, this 20. So up to 7 pounds, I only have it adding a little bit of fuel. That's not enough. I got to add more now. So I'm going to borrow this 8.7, 8.2 column, and I'm going to go up one. I'm going to use that as my new 7 pounds. Now, do I like that? I don't like that. I think that 7 pounds, well, it's not quite 7, it's 6 pounds, but that 6 pounds jump is too big. I want to add a spot in there because I don't like that. I'm going to add a spot at 16 and a half. Like that. Let it turbulate, sure, that's fine. I'm still going to add fuel to it though. 8.5, 9.5, 8.6. I don't like that much. Let's change that. Okay. So now we've richened it up at a few pounds of boost. Maybe a smidge too much, maybe not enough. This, however, is not enough. This is 7.8 is not rich enough for pump gas to be doing 20-something pounds of boost. So we got to richen that up quite a bit. So we don't want it to be lean. And I'm going to do this. Really, this machine's only going to run like 12 pounds or so. It's got the stock turbo on it, so it's not going to be a boost monster. But we still want it to be rich enough to be safe. 6 and 6 is 12. That's not enough, and it's more right there. Go 7.6 here. So 7.6 for you AFR folks is right around 11.3, if I recall correctly. I've been tuning in Lambda for a while, so I just forget what they are in AFR units. But we're adding fuel, make sure it's rich. I know that the fuel map already has it pretty close to that rich. So this is the formality at this point for the targets. This thing's running kind of consistently warm. I got fans on the front, you got the fans on the radiator, and it hit 207 pretty easily. So that's not ideal. So we'll keep our eye on that. Okay, that one's really rich right there. Still pulling a ton of fuel out. Still pulling a butt whack of fuel out, which is good. I'm happy with that because that means it was safe. Okay, this whole section here I got pumped up. I just pulled 12% out of it. I don't know if that window pops up. I don't think it does. Um, is that rev hang? Oh, throttle sticking. That's why. See the throttle saying 1.4? So the throttle is sticking a little bit. That could be the cable. That could be the butterfly. That could be a few things, but aftermarket throttle bodies like this sometimes do that. So you see there, it was actually at 1.4. So that hang was actually the throttle body sticking. Um, so we'll have to look at that and see if it's the cable hanging up or whatever. But it's not important for this part of the phase that we're doing. And the owner will know that, and he'll be able to address that in the future on his own if he wants. So, okay. Nope, that ain't it. That ain't it. That's a shame. It's not letting me do it. Well, I can't show you. Sorry about that. There's a window that says enter new value, and you can choose to hit equals a value, minus a value, add a value, multiply a value, divide a value, whatever. You can do whatever. You just do it by hitting that key. You see. All right, well, I can't show you. Bummer. Sorry about that. All right, so now we're going to go and check that spot again. I just pulled 12% out of on the map right there. All right, here's atmospheric. Here it's adding 4%. All right, we're going to 2 pounds of boost. That's about 3 or 4 pounds right there. Oh, 5 pounds. Pulling 3%. I like that. I like pulling 3%. That appeals to me because, as you guys know, I like it to be a little rich. I always rather the ECU have to pull fuel than add fuel. Pulling fuel is safe. It means that it's safer in the event that the O2 sensor fails for some reason, or the closed control system goes open on us, or who knows, whatever can happen. I'd rather that it was on the rich side than have to do work to make it rich enough to make it safe. So that's good. I'm happy with that. Let's check the boost control system real quick before I start getting boost up. All right, so she's on wastegate pressure. I don't know what that is on this yet because I haven't done a 0 PSI pull, done any pulls. Okay, so we did 2200 RPM. Now we're going to bump the RPM up a bit by doing this in third gear, and we'll get a higher RPM range on it. Okay, so now you see we're like 28-ish. Adding 5, adding 4, adding 3. Okay, so the lower area here needs some fuel, but the upper area did not. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 150 151 152 153 154 155 156 157 158 159 160 machine a little bit. Try it again. Pulling two, pulling two, pulling three. All right, like that. That's what I like. Pulling 2 to 5 is like my goal. I mean, it's nice to have it say 0, and be like, oh look, it's perfectly at 0. But when different environmental conditions occur, it won't be perfectly at 0. All right, now we're going to second. Look at this charge temp, and it seems to me that the charge temp is high. But that's only because this coolant temp is so high. If you look at, we got 50% split. Oh yeah, TPS sticking again. It all sticks. Little bump, get a bump. Well, there he goes. All right. So at that higher RPM, at this RPM, we're at 57%. So 50%, 7% means that the intake charge temperature is biased 57% to coolant temp, and the other 43% to the IAT. This makes sense when you have very low airflow in the engine, like you do with idle. The air that's in there has had lots of time to absorb heat or be heated up by residual heat in the combustion chamber from, whatever was sitting there from the previous combustion event. As you increase the airflow, that number dips down to lower values, 20, 10, whatever. You see 10 here at the peak. That means that the air is moving so fast, plus there's a lot of fuel going in there. It cools that charge temperature down, and it's just better. But you don't need to have as much of the bias towards the coolant temp. So cooler charge temps are great. Let's see. But accurate charge temp is even greater. Let's see what we got. All right, so that was good. Everything's been really good. Honestly, at this point, everything's really good. I got a little correction right now at idle. And it's climbing some. Some of that could be because I do have so much bias towards the coolant temp. So if I took this right now and made this 45, which is much lower than you usually have it at this RPM and load, you can see the charge temperature here, the 139, changed immediately. If I go back to 57, see now it's 149. Now also we can watch the lambda being 0.96 with 7778 correction. If I make this 30, which is definitely not accurate, then bam, all of a sudden lambda richens up, this correction starts to drop, and this temperature drops. So you can see the effect of the calculated charge temperature has on the amount of fuel injected. Now, yeah, my correction is getting closer, everything's getting closer. Does that mean that this was wrong? No, it means that my VE was wrong there. Or I didn't compensate for other factors, because it's almost never going to be as low as 30-something in idle. It's just like almost never going to happen. Okay. Now, we can look over here and go, 65 is kind of high VE for idle. However, this is a very high idle. We're up here at 1,000 RPM, so the VE is going to be a little better than a normal car would have it. Typically, we're idling down here, and the VEs here are usually in the 50s. This one's not. This one still says 65, but that's fine because we don't go down there because this thing doesn't do it. The only time we actually go down there is when it's cold. Now, other changes in this could be these injectors are a generic 725 injector, so injector latency could be off a tiny bit based on voltage. Oh, I didn't look at voltage. What is voltage? This thing had a dead battery earlier, so I don't have battery voltage on here. Oh yeah, see, we're only at 11.1 right now, so that's a concern. Not a voltage. We're not at a full 14.4. Again, the 12 volt internal is only at 10.8. Okay, so that's an issue, but that does tell me one thing. That gives me the opportunity to look at that injector because it wasn't that far off when it was higher voltage. So this is not enough. I got to raise the the low voltage slope. I did not add enough slope to it. The 14 was good because that was where I tested it before. So we got to add to here, add to here, add to here. That's probably better for these injectors. There we go. And that makes more sense. I thought this VE seemed a smidge high in the first place, so we'll lower that back down. Like 64, 65. And, that's a little better. Okay, now we're pulling a bunch of fuel. So I might have went a little too far, but that's all right. Didn't have much. It's amazing how much. So, like, you can really tell that we're right on the edge of what the actual latency is by how sensitive this system gets right here. There we go. I like that. This spot's a little hot. All right, I like that. Question is, can we get more voltage on this machine? That's one thing we gotta do. Let's do a store. I haven't performed a store in a while, so we do a store, do a save. All right, saved and stored. Correction now is 0.2, 0.96 lambda. At my low voltage, that all makes sense. All that looks really good. So I'm going to try and do a pull at the low voltage and see if our ignition system is strong enough for that. We're also going to see what boost pressure is. I don't know what it's going to do on wastegate. You guys set the dyno for a pull. I'm going to set the track on the dyno so it knows what RPM the engine is. Now I go to dyno mode. Grab something. I guess put this graph on there. Let's get rid of that. Put my interfield trace on here. I have one in the tailpipe. I have one here on the link as well. I'll definitely be looking at both of them. All right. Now we're set. Wow. Oh, got that throttle hang. There it is. All right. So my wow was the torque graph. That torque curve is flat. Look at that. That's a good time when the torque curve is that flat. That means the horsepower is a 45-degree angle. Yeah, let's bring the power up. You can see it. That's pretty cool. You can barely see it on that camera, huh? It's not the greatest view. You can get a little phone holder thing. Look at that. Nice. Up the red line there. Alright, my AFR did not track on the dyno. I might not have plugged it in. I thought I did. I'll check that. But I saw it was also really rich during the pull, which is good. I like it rich to start off with. So let's go. Let's see what we got. What do we got? 10 pounds of boost. Okay, I like that. Basically 10 pounds the whole way. Timing was 16 to 20. RBs like the timing. RBs are a lot like an EJ and what they like for timing. AFR is really rich. So at the beginning of the pull, it's really, really, really rich. At the end of the pull, it's not. Um, I don't know how much of that yet is due to closed loop control and how much is not. Let's see. Closed loop pulling 5% up top, and it didn't have an opportunity to pull any down here in this really rich area. All right, so we're going to check this area on the map and see what she looks like. Go to fuel. Look at the pink line. Pink line is where we were. Let me look at this and go 4%, 4%, 4%, 4%, 4%, 4%. So I got a 4% increase all the way up, which clearly is too steep of a curve. You can see it here. It's a pretty linear curve, and I got a little fuzziness here to fix over there too. So we just need to bring this curve down to less than 4%. They're almost never 4%. That's just per jump. That's a big jump, but it's a great start. So this. Okay, so now we got 95 and 98. That's a pretty significant drop right there. Oops. So fuel table right here was 102. That's where it was originally. I can always go back and check that. I can go back to the parameter list, see what it was. It was 102.5, and then I can go back and verify that I didn't pull too much out. And now it's 96-ish, 97-ish right there. So that's great. Um, that'll definitely get the air fuel closer to where you want it. Let's go back to the log again. And we're going to check right here. That red line is over 5%. And it was still richer than target. But I think I'm going to richen the target up there a little bit, actually. I'll richen the target some instead of making it leaner there. I'm going to add to it. Oh, big change. Yeah, I like that better. Okay, that's good. We're just thinking ethanol. Ethanol makes it a lot of fun. All right, let's do it again. Oh, I'm going to check the dyno AFR, see if I get that working. Oh, okay. Oh, I see it now. It was just that rich. It's just that rich. All right, well, we definitely added power in the low range where it was really, really rich. Top end didn't change any, but that's expected. I didn't change boost, I didn't change ignition, I didn't change fuel on the top end, so I wouldn't expect it to be a whole lot different. I do want to check that battery voltage, though. I feel like it might be dropping somewhere. Let's see where we're at. Should put it on this graph here, actually. Do that. Do it right here. I think I heard a little bit of a boost leak. I think I heard some squeal. Um, could have been tires on rollers, but I think I heard a boost leak. Really small. If it was, it's really small. Oh yeah, we're down to 10.5 volts. So alternator is not working. Okay. Yeah, we're still pulling a lot of fuel out right here. Let's go back to the map again. Find that zone. So there is quite a bit of fuel pulled out. Switch it there. All this can come down now. Verify that that's too much. Alright, I don't know how many more pulls we got. This charger's not enough. The alternator is definitely not charging the car. Otherwise, I'd have 14 right now. This alternator is definitely not working. I've got 2 batteries on it. That's probably why it's been so stable, and a charger. But we need more juice. Turn the fans off. That might raise the voltage some for us. That helped. That raised it. Okay. Alright, let's try another pull. Let's figure that area leaned out adequately. Alright, more came out of it. That's good. Yeah.
You care if I take the jumper tables off of the chassis?
That should be okay for now. Why? What's up?
Do we get another battery to that?
Oh, yeah. Yeah, it's down to 10.5 volts. The alternator's not charging.
I got a fully charged battery.
Okay.
It's a deep cycle. I don't think I have the other jump box. I don't believe it's charged. And I'm guessing the charger's barely keeping up with your laptop use plug.
Hold on a second. Don't do that. Well, for one, that's negative. But then also, is the other half totally disconnected?
Yeah.
Okay, make sure. I'll pull that off. Just to drain at this point. There you go.
Nothing?
No, nothing. Well, the alternator's not making it because
Oh,
no. I don't think that bottom of that post is connected on that deep cycle.
we have any volts or no?
Waiting for it to connect. Last.
Last? Last is the jump box or the battery for the top.
Oh, it's dropped some more. Yeah, you pulled the jump box off, it dropped more, so. I don't think that's got a good connection on that battery over there. Sure that's charged?
Huh?
You sure that's charged?
Just checked it.
And you had what? Yeah, it's not giving us anything.
Yes. Okay, thank you.
Yeah, there's no difference.
Let me see if I can do this.
Yeah, that went up.
That went up?
That battery must not be charged. What did?
Just
And it was 12 volts or what?
12.4.
Weird.
Okay, well, we got this interstate back here and see if that says yay or nay. Yeah. That better?
Yeah, that went up a bunch. It's still only 11.8, obviously, but
Give it some action.
11.8 is better than 10.5.
How's the battery? Is the jump box drawing it down now?
Yeah,
Back up?
11.7.
Yeah, I think it's actually taking power.
At that point, yeah. Well, I'm pretty much done. I just need to do like one more poll. So that should help.
Yeah, run that out again.
Yep. Turn the fans back on. See if we can get a little lower temp before I start the poll. I don't actually dropping any though. I did puke quite a bit of water out at the beginning, so I might have a significant air pocket in there. Like that. It's basically pulling 2% almost the whole way. That's like exactly what I want. It's a little rich through here. But it's burning it. See if this wastegate works. No, I didn't change the output at all. I didn't change the output at all. So the answer to that is no, it doesn't work, which is fine. It's all the slow turbos you're gonna do on this thing anyway. I mean, you can do more in the lower range, but the owner expressed that he liked the way it was power-wise, and he just wanted it all cleaned up. So that's where we're at. I'm gonna go talk to him here in a second. Make sure all of that still is in line with what he desires. Make sure my store worked correctly. If it didn't work, it'll say the settings are different. Oh, they worked great. I'll say the settings are different. Excellent. Hey, Mark. Welcome. Sorry I missed your message there. Trying to get this little RB20 going. Seems pretty good. We got an alternator not charging issue. We're going to try and address that. Otherwise, it's done excellent so far. So no other issues. Push control and everything. But I don't know how the wastegate's set up on this or not. But it's extremely flat torque curve, as you can see by the dynagraph there. Actually, need to get rid of all these junk runs that I just did. What's the last solid run? What's the blue one? The blue one is that one. Okay. It's hard to see from over here. All right, get closer. So you got a bigger screen. Fancy.
Foldable screen.
Yeah.
Yeah.
Yeah, it's big. So, oh, that's us.
Okay.
Internet's going to hear you. So that's what you do. Look at that torque curve. That's great.
Yeah.
That's nice and flat. It just follows the boost curve pretty much. It holds pretty much 10 pounds of boost across the whole power band. That's wastegate pressure on that turbo.
Okay.
I haven't cranked up the wastegate use. I tried, but the boost didn't go up. So I don't know if it's not hooked up or hoses or what. But I know you said you didn't want a ton of power, so I didn't. I was like, I just want to see if it's working, you know.
Yeah.
But you said it was fine the way it was. You like the power from before?
Oh, it's fast.
Okay.
It felt. I mean,
it's a light car, so.
Yeah.
Yeah.
I mean, I didn't get hard on it. I mean.
That's about 295 at the crankshaft.
Yeah.
So that's about 295 that it makes, which is
Perfect.
3 horsepower car that weighs 1,900 pounds, or that weighs.
It's probably going to be faster than it was when I drove before, or just smoother.
Definitely smoother for sure. Yeah. As far as more power, I don't know. I know that it's not as rich as it was because it was set really rich before, like I said, for safety until we can get on the dyno. Air fuels are good now, and but it'll do more of whatever we want. You know, like if we want more boost and more power, we can do that at some point. So
okay. I'm super happy with what I had before.
Excellent. So we just need to figure out why the alternator is not charging. That's the one, and
I'm gonna have to put it on my list, get in there,
and see what the hell's going on under there.
If I can't find a wire issue, then I'll
Yeah, that's pretty simple. Test the
I gotta figure
alternator.
out how to get it.
Oh, sure, right, because it's 10.5 volts
When I got here, it was at 45%
percent.
full charge. 45%.
Yeah. The link will run down to about 8.5. So you got some, but you left on a full charge though. You said, oh yeah, so you used 55% getting here. Hmm.
So unless someone wants to go get me a battery, and I'll just buy a brand new battery and get home. Or
It sucked to buy a battery when it's not the problem.
yeah, shit, no. I've got 20 vehicles in my house. I'll use a battery.
Okay, do you have any class? What other vehicles do you have? Because we can get one that's a class for the other vehicles. Since yours is universal in the back of the car, you might as well get one that applies to the other stuff you have too.
The battery is in the back of the car.
Yeah,
Pick it out of my
gotcha.
It's definitely the battery. Or the
Alternator. Yeah.
That
Yeah.
shows.
Mm-hmm.
Will that show on that video?
It'll show it. It'll display it as battery voltage, but it's supply voltage. Right. Yeah. It'll display the supply voltage, or it'll display the supply voltage to the ECU. Yeah. So that's actually one thing I'm going to do here now is I'm going to go plug that gauge in, see if I have the protocol correct.
Okay.
But to do that, I got to unplug the O2 sensor. But I'm going to do that just one to get everything set up, and then figure out if I can either T-tap or if we can build a Y or whatever to get them both right at the same time.
Okay. Sweet.
So I'll do that, and while that's happening, I'll put the charger on your battery and have it charge while I'm doing that. %. Ooh, that's low. All right. Right. So it says 2%. The charge is 2%. Yeah. So the right charge. Yeah, a little better.
If I want to run the fan. I mean, what's
Yeah. Well, it depends on what your cap pressure is set to. The function of the one. If it was atmosphere pressure, no pressure in the system, then each one is boils. So it's supposed to boil. So with a few pounds in it, it bumps that pressure up. Yeah, 220, 230 is about the highest I want to go. Yeah, power of some sort. But we can check continuity from the alternator back. Just make sure that it's got good continuity, nothing that came free. Right? I'm going to work on this while the battery charges anyways. See if we got the right plug for this setup or not.
Had two wires going together.
Oh, yeah. I see right here. Yeah.
I don't know. Does that loose?
No.
We had one of those.
Oh, it would have to be from the alternator to the fuse box because the EC gets power from the fuse box. Alternator goes fuse box and battery. So they have to go into the fuse box. Otherwise, we'd have power when it's running.
Gotcha.
So that have to be down there, that one spot. Okay, so this is the other side. That's not the right plug. That might be okay. That might actually work out if. Yeah, just clicked on that one and that one, or that one there, which are connected. Yeah, it's on there.
Oh, the charger I got. Yeah. So it is charging. So it's at 45%.
Weird. Yeah, that's what it says. It said 2% earlier.
It takes maybe a second to figure it out.
Gotcha.
But that's between the two batteries. If you put
That's
it just on that one.
it's off here.
Oh, yeah, you're right.
Yeah, it's only on one battery.
Okay. Well, that would make me feel a little better.
Elaine, give me these. That's a trick question. I know you do.
I have the wrong one.
Go the other side. That's what I need. The other side.
The female?
I need a couple of them. Or I need to tap this into the existing setup. I either need to build a Y system for it, or tap it in the existing one.
No, no, this is the wrong one. That's fine.
That's up big. That's the DT one.
Yep.
That's
These ones
the
are the
DT.
right ones. Yes. You just need the female?
Well, I'll probably need a couple. I got to build a thing for it, so I'm trying to figure out how I should do it. I'd like to add a plug. So basically, what we have is we have a CAN bus, and right now we have the Link CAN Lambda in it. I need to add this.
Oh, so you just need to make a splitter.
But you already have a wire on there that you're using as an extender. I should make that a splitter. I should split the one side into this.
Yeah, into this.
And you put this into the pins that go into the one.
Yeah.
What size wire did you use? Is it small to fit two wires on one pin, or should I just vampire tap this bitch on there? Yeah, 3 or 4.
No. You only need 2, right?
No, I need power and ground still. If I did 4, I'd have power, ground, and everything.
Well, I'll tell you what. Just
this gauge is ship
shrink
power.
No, I got an idea. You're just gonna. How long is that other harness? The one that's existing.
It goes through the firewall, the one that you made.
Okay. So what you can do is nip that, solder 2 to 1, 2 to 1, 2 to 1, and shrink back over it. Do that. Then you don't have to vampire tap in because I only have 2 of those stupid things.
They're awesome things. They work really well every time I need one.
Yes.
It's stupid that you only have 2 of them. Is what you have to say?
That's exactly right. Oh, here's the. I cut off that valve, the combination valve.
Oh, sweet.
And the connector, so I have male and female matings.
Perfect. Yeah, I could take that, model it, and give it to one of the.
But yeah, that's all I got there. That's what I would do.
You have pins for these, right?
Yes.
These are the male pin.
Yeah, I don't have any of the other side though.
So if you just have the male pins, that's not bad, because this is.
I think Tanner handed me a Deutsch connector the other day.
Male. Oh, I got this idea. What's this?
The
The gear
box
shifter thing.
thing.
Okay, so what if we do this? Take 2 of these. No, we don't need 2. We only need 1. We just need. I need 8 male pins for these. Where are those at?
They're in there. They're in that bag with them.
In here. Okay, how much wire can these hold? This is pretty small fucking gauge right here.
Yep.
So if I
Well,
put,
those are crimp overs too, not barrels.
Oh, these ones here.
No, the pins.
Yeah.
Are open, not round.
Right.
So you can put a lot more wire in it.
Well, it fits inside here.
It'll fit inside there.
So then,
I've put like.
do you have small
16.
wire like this?
Yep. Good.
How small you got?
That's it.
Smaller, better.
Let's see.
Because if we had really small, I could put 2 per pin, like this, right? Oh, those are singles.
Let's see if my A and B room has anything small on it.
It's pretty small. This is pretty small. Is it smaller than this one? This is small too.
I think the shielding is a little bit small.
4 small ones would be great. And I only need like 8 inches. Oh, the date?
2012.
Yeah, I think mine are the same.
They were sealed in the package.
Yeah, I have a set that's also in the package. It's probably old as fuck.
These are the ones that Adam bought for his 240 in the first hand, and then you switched them to some other stuff, so he didn't end up using this. He used a plug and play or an adapter harness or something like that.
Yeah, so if we use 8 inches of that, a small wire, then I put 2 wires on the 1 pin on the one that goes into the board, bring that out, and put it into this one. So then it becomes a Y.
Yeah.
So I just need 8 inches of 40 different color wires. They're small. Smallest you got.
I mean, these look to be all the same. I just don't know which ones are which. I think it's way too long for what I need my RX-7 anyway.
Oh,
I should
for
just
sure.
stretch that out.
Yeah, you're not going to have it in the trunk.
No, the ECU is about this far from the engine. Okay, so we can pull anything off any of them. What color do you want?
I mean, the closest to this, the better.
Red, white, green, and black? You want to just do red, white, green, black?
Okay. Is that this one? This one has that.
I don't have any white in here.
So that's plenty of white. It says green and red and white and black.
Works for me.
Green. White.
Did I show you these little guys?
Yes, you showed me yesterday.
Just a second.
I just lost it. Just saw it. From the bitch. These. You're just circumcising it.
Oh. Well, it grows back, so I'm going to have to do it again.
I wish.
Something about like
That's
that.
good enough, yeah.
Hey, for an F-150, if someone wanted to buy brakes, would I want semi-metallic or ceramic on there?
Either.
Either?
What's he do? Just tow with it?
Just regular dude driving shit.
Probably ceramic.
Yeah, ceramic would be fine.
If he was doing a lot of towing, I'd go with like some semi-metallics or something.
I know ceramics remember what I go with, but then I looked and I said, oh, you use semi-metallic, and I was like,
Oh, they do OE then.
I would do the Informer. So like.
But I'd do some composition as a better one.
Yeah. That's what I have in my truck.
For that. Crimpers. Terminal ones. Wait for. Thank you. Oh, I need needle nose to pull the thing out of the other one. Gracias. Oh yes. So I don't know if anyone's even here anymore, but if you are, what I'm doing here is I'm just building a harness for the can lambda and for the gauge, the BTI gauge to both go to the link. Right now, the one that I got is the wrong gauge. Can you let us know about new gauge roads that you're selling now? If you're going to be selling more of your modified cover games. Are you still here? I know I was gone for a while there. So right now, my rods are being made. These are good. Thank you. They are it's like a two-phase thing. So I don't know how much you know. I've been involved in aviation stuff, and one of the projects I'm on, we're building an engine from scratch. I can't tell you about the engine because I signed an NDA to a really rich guy, so that's never a good idea to violate those. So, but anyways, we're doing something nobody's ever done before, and this guy's also designing an airplane. And when you design a new engine in a new aircraft, it's never a good idea to test a new engine in a new aircraft. It's not a good idea. You just imagine that. Here's a new airframe. Hopefully it flies. Here's a new engine. Hopefully it makes power, right? I mean, no, it does not mean that. So what it means, though, is that I have two versions of the rods. One of them is a new design or new features on a proven design. And then the next one will be a new design with those new features that will hopefully be proven on the design. So the idea is don't change everything. Attack one thing at a time. Because I think I'm going to figure it out. Yeah. All right. So I have there we go. I have been working on preventing vent wrist pins for quite some time, and it has been such a freaking hassle because nobody makes the rods and pistons the right way. Plain and simple. And take a picture of this harness real quick before I take it apart. Should I remember where the wires go? Okay. Nobody's making this the right way. And this can sound funny because I say it all the time, except for the OEMs. They've been doing it. So there are some significant differences between OEM factory STI rods, for example, and aftermarket rods. Some of them are clearly beneficial for the reasons of strength and that kind of stuff. But some of them are done in the interest, or what I believe to be in the interest of economy. And because of that interest of economy, we have been running weaker rods than we should have been. And they're weaker not in the horsepower sense, but in the wrist pin stability sense. Are you following? And what's resulted in is a bunch of fucking wrist pins are bent on pistons. I mean, I shit you not, it's near 100% of built motors that get disassembled, whether we built it or anybody else. We take them apart after they've made some power, the wrist pins are bent. I shit you not, it is almost 100% of every fucking engine we've taken apart that's made any sort of significant horsepower and the wrist pins are no longer straight. And one second, let me get this. I need a pin to undo the pins. Which one? All right, that one. Thicker. Can't bend it. Can't break it. All right. Now, when I was at MPS and we were building engines, I was doing hundreds of engines a year. Craig was building almost an engine a day. It's not an engine a day. Sometimes 2 engines in a day. Sometimes not, based on whatever. So, I have Insane's build the rods. No, never again, honestly. I would never have them build me rods ever again. Every rod that they ever made for me had significant issues. My MPS Super H's that I had them to do back in like 2010, where the hell it was. Beautiful rod. But the wrist pin bushings on them, on every single one, squished out of the rod. Became oval. I can't tell if they were using an inferior alloy for their bushing, or if they weren't providing enough stability or material steel behind the bushing to give it strength, and it was like oval. But every single one of those rods I've taken apart, squished the bushing out of them. So, and the representative over here in the U.S., I don't know if it's the same dude or not. Holy shit, is that dude bad at communicating, bad at following through, bad at just every aspect of it. It was a miserable experience working with those guys. Now, that was 10 plus years ago, so maybe things have changed, but I never want to do business with those guys again if the same people are still working there. Because it was just horrid. The whole process was just a nightmare. So no, definitely not them. So, anyways, what I'm getting at is that I have new features to combat wrist pin issues. Is this one through? No, that's just dirt. Okay. So new features to combat wrist pin issues, and then later I will release my other rod design, which has features to increase strength above other rods on the market. Or so my simulations have proved, right? And that's just my simulations on those. And that's why I'm not doing both at the same time. Because I don't know if my rod design, the new design, is going to be stronger than what's already on the market. I have no way of knowing that. I mean, simulations say it will be, but simulations are not real life sometimes. So the features I'm adding to an existing rod that is known to handle strength, or known to handle power, and then the features are to improve or reduce the chances of wrist pin bendage. And then later on down the line, after those have been proven, and the market understands that they're proven, then I will eventually release my other rod design. I call it the K-beam. There's A-beams, I-beams, all kinds of beams, X-beams, whatever. Mine's the K-beam. I'm excited about it because I spent a lot of time doing it, and in simulations, it was stronger than just about every freaking rod so I took all the competitors' rods, all the ones on the market, except for a couple. I modeled them, and then I ran the same tests on all of them. And in every case, my rod was stronger against twisting, so torsion, and tensile, and compression. So tensile, tension, torsion, etc. It was stronger than the ones on the market, while also being lighter. Now, the issue is you'd go, why isn't that why isn't every rod built that way then? And that's again, that's where the economy comes in. This rod will cost more to make because it is more complex to make. So it will not be an economy rod in that regard. It won't be ridiculously high titanium rod pricing or some of the other manufacturers where you're like, why is that rod that expensive? And it's nothing other than they put their name on it and their name is big. It's not going to be like that. So you don't got to worry about it being, you know, $2,000 for a set of rods or something. It won't be like that. Well, I mean, I don't think it will until I get, cost of manufacture. But if it's going to be that much per set, I might not even build them, to be honest with you. These other rods I'm having done right now with the features for the wrist pins and everything. Now, the pistons have to match, right? That's why I can't just sell these rods to somebody because they're not going to work with regular pistons. The pistons are being built by JE to match the rod that I had built for 2 liters and 2.5s for both. So that should be fun. But what were you going to say about that? Oh, I don't even know how much the other ones are going to cost, but these are going to be around probably around $800 for the set for these, for the rods, and the pistons will be standard piston prices. A custom set of pistons with ceramic coating and ports and things like that are usually around $800. So it'll be around probably close-ish to $2,000 for rods and pistons that have stronger wrist pin and support and etc. than any other piston made for Subaru. So we'll see. I've already paid for the rods. I've got, what did I do? I think I did just a small run. I think 30 rods, I think is what I did. Maybe it was 50 rods. I don't recall, something like that. Honestly, I've been doing so many numbers. I've given so much money to people in the last freaking month that it's scary. We have all these products coming out and stuff. So it's scary to hand out that much money and not know if it's going to sell or not. If that shit doesn't sell, you're like, well, I'm in the poorhouse now. Nothing I can do about that. Sorry, honey. I made us broke. So that's a little nerve-wracking. Some power, 400 wheel, 500 wheel. It ain't much. It happens all the time, especially if it's on ethanol. All the freaking time. Really? It's such a pain in the ass. I hate handling little tiny wires trying to do this. Hope that worked. There comes the blind. Let's see. Flip it over. Check the print. I got it. Oh, that's pretty snug, actually. Sweet. Right. You put a little more torque on that. But yeah, this wrist pin thing is like an epidemic. People don't realize it. So, symptoms of wrist pins being bent. One day you start your engine, and it just seems louder. Like a piston slaps louder than it was before. You're like, huh, this slap seems kind of loud. I remember before it was, like a certain tone, but now it seems louder. And it seems more solid, or maybe not even solid, maybe I should say hollow. Like it's more of a thump, thump, thump instead of the ta-ta-ta-ta-ta that you get. this funky sound that you hear is the piston wiggling even more because the wrist pin isn't rotating freely between the pin and the piston anymore. Like, the pin's not rotating freely inside the bore between the piston and the rod. And so the piston now is moving around even more. And when the rod comes around, it's pushing on the piston, so thunk, 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 thunk. So your piston slap gets louder, feels more intense. And like, wow, this engine's wearing out. That's usually because your wrist pin's bent. And like I said, nearly every car in ethanol is gonna experience that at some point. Nearly every freaking car. And it's crazy because I've had cars that were making 500 wheel on stock long blocks or stock rods and pistons. Never seen a bent factory pin. To this day, never seen a bent factory pin. And that was what really flew me in. Is that every time I pulled a wrist pin out of a stock motor, it came out smoothly. And I was like, what the hell? I'm using fancy alloys and thicker pins than the factory, spending an extra $30 to $50 per wrist pin in some cases to try and get the strongest wrist pins available. And it didn't matter. It didn't freaking matter. Every time, bent pins. But every time I pulled apart a factory engine, not bent pins. So I was like, what is the factory doing right that the aftermarket's doing wrong? So I spent years, as always, analyzing that. And I ran a bunch of simulations. And wow, that wasn't good, was it? That crimp good? Nope, that crimp was not good. I ran a bunch of simulations. And the simulation showed that my wrist pin boss design in the piston and the pin reduced peak forces on the pin or localized forces on the pin that caused the bending of the pin by down to a third. So basically, aftermarket rods and pistons have 300% more bending force and more localized force than my design does, according to simulations. So mine was 30% of what the aftermarket rods was. And it was insane because it wasn't even just like this one tiny spot. Yeah, one tiny spot right at the exact point that all of those wrist pin bushings in the Sans rods and every other freaking rod was squishing out. That exact point, that same small area, is where that highest force concentration was. And I was like, oh, look at that. That's exactly where we're having the problem. And my design reduced that down to 30% of what it was. God dang it. This is not fun. This is such a pain in the ass because the wires are so close together. You're trying to run the crimper, and things are getting stuck in the other jaw of the crimper, and you're trying to. This sucks. It's alright. It'll work. In the end, it'll all work. And 2 out of 4. All that time for 2. Yes. Yep, that's correct. It was mostly, well, yes, both, but um, it was more apparent at the uh, rod because the piston has twice as much area. Think about the rod's only 8 something wide. Was it 847? I think it is 0.847 inches wide, and each wrist pin boss in the piston is at least that wide. Which you see there could be some of the problem. I have all this force in the piston being pushed onto a tiny skinny rod. But yeah, so the piston had all the surface area and was able to push down that piston pin, and the rod only being this wide, and the spacing and the angle and all that shit all came into it. That's what's different, because aftermarket rods and factory rods are the same width. If you want to say wobble, you can say wobble, but it's deforming the pin around the rod. And when I show my rods and I release them, I will give full explanations. So you'll get to see what I mean. I will provide the simulation results. I'll provide the design data and all of that. But until then, I'm not being super specific because they're not released yet. When they are, you'll get to see all that stuff. You look at it, and even you'll go, oh, motherfucker. I'll be darned. Because it'll make sense. Basically, my rod is a diesel rod for an EJ. I guess that's a good way of putting it. It's made for a lot of cylinder pressure, which is what we get when we have an EJ on ethanol. Just a lot of cylinder pressure. Correct, yeah, because as you know, you can't use aftermarket rods on factory pistons. You can use aftermarket pistons on factory rods, but it's not a good idea. Mark Villaredo. Isn't your name close to the guy that like works at Torque Solutions? It's for the Torque Solutions guy's name was something like that too. You guys related? Um, favorite bearing around your rods? Um, well, kinda, kinda, but not really. So rod bearings matter. don't matter that much, honestly. The thing that's important about rod bearings is that they're the correct material, which is most of them are the correct material. That's all you're going to get. And okay, green goes in this corner, and that they're round where they need to be round and consistent. Right? Really, consistency is the key. That's the biggest thing. But the rod bearing itself isn't as important as getting oil to it. Basically, what I'm trying to say. It's definitely more important to have a shitty bearing with oil than a fancy, expensive bearing with no oil. And the Subaru issue is getting oil to the bearing more than it is any of those other things, you know. So, do I have a special rod bearing that I like? Yeah, I mean, I run either King or ACL for the rods. They seem pretty good. And my own stuff, what do I run? Cleveite. I like to run Clevites. My preferred order is Cleveite, ACL, King. But when it comes to the rods, I don't really care that much. It's the main bearings that I care about. The main bearing is my biggest concern because, like I said, it's more important to get oil to the bearing than to have a fancy bearing. And the Kings are really bad. The main bearings are really bad at getting oil to the bearing. It's just been the case over and over and over again. They're dumping off too much oil pressure from the mains for whatever reason, based on which revision of the bearing it was. First, it was way too many feed holes to the thrust bearing, dumping main pressure. They had, you look at the factory bearing versus an ACL bearing or versus the King bearing back in the day, like 2010-ish day. They had like 8 feed holes to the thrust bearing, and it was just killing oil pressure. And you look at their next design, and there was less feed holes to the thrust bearing because they're like, oh shit, we're killing oil pressure. But their quality control has gone downhill dramatically. Holy shit. Get bent bearings and shit from them out of the box. Like, seriously? Like, brand new freaking. Say what? Sure. Just pull it. Brand new bearings out of the box. Bent to shit. Yeah, I don't know why it's sticking. It could be a physical interference, you know? This bastard. This fucking wire. Get this wire in here. It's just being stubborn. So, anyways, like I said, more important to have oil to it than just to have a fancy coating or a slightly different material with, you know, this one's got like, oh, an extra 10,000th of freaking coating on it, and it helps oil stick to it, and blah, 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 whatever. There's no fucking oil, then it ain't gonna work. We're at the point now here at the shop where we don't ever recommend 2.5s anymore. Just fuck them. They're just so terrible. They're so weak, so floppy and flimsy, and the new blocks are just horrendous, bad. And so now we're just in the 2-liter phase. Like, fuck it. Put a 2.5 in it. Or a 2.3. And the reason I say a 2.3 is because, yes, it's still a 2.5 block, but they make less torque. And the crank is more rigid. The cranks are stiffer in a 2.3 than they are in a 2.5 because you use a 2-liter crank, which is stiffer than a 2.5 crank. What's that? Oh, the Audi's here. I really thought I was going to have time between this and the Audi to do the other car. The Audi was late, though. That's funny. They said they were going to be late. Come on. Well, this is tough. I'm yanking 2 wires through where 1 wire goes. I think I got it. I think I'm good. I think I'm good. Is shit still working? Alright. I think it goes just like this. It's a twin turbo Audi R8 that's here today. I'm not tuning it, I just run the dyno for it. I have my friend John tune it remotely. Which is fine with me. I've never tuned an Audi R8. I've done. Last thing I want to do is do one that's fucking 1200 horsepower. It's my first one. Some people do that though. Some people are so fucking arrogant. They're like, whatever, I'll tune whatever. And I will tune whatever. But I'm honest with people. Like, yo, I've never done it before. You know, like, I can't guarantee anything. There's probably a better guy out there for it than me. You know, I mean, maybe not somebody who will pay as much attention to things while learning than me, but maybe not even with as much base knowledge as I have. You know, I don't know, but somebody with the experience and the time that they put into it that I haven't, or more. I don't know. There's people out there, definitely. Lots of people out there smarter than me. I'm a fucking idiot. I mean, I've made some mistakes. Let's see. Oh, that one. That was not my seat. No, I have not. I have not.
Is that your next tune?
Yeah.
Holy crap.
I'm not actually tuning it. I'm just running the dyno for the guy that's tuning it.
Oh, yeah?
The guy that's tuning it's a friend of mine. Is that in? Feels like it's in. That one goes too far. I've never tuned an R8.
Aren't they naturally aspirated?
They usually are. But as you can see, that one's not.
No, twin turbo.
Yeah, 2 of
Holy
them
crap.
hanging out the back. There we go. I get it. Ouch. What does it say?
52. Huh, 92.
Weird.
Put it right on the battery. Now it's at 92.
That's weird. I'd be surprised if it was that charged after only that much time. Well, that didn't fucking work. How did that do that? Seems like it's in place. That's in place, but that pin is bent. I don't know if that's gonna work. Maybe. Maybe. Let's see if it works. Is it neutral? Oh, turn off the fuel pump?
Yeah.
Gotcha. That's fine. I got what I wanted out of it.
Oh, okay.
Yep.
You gonna leave the key on?
Just for now.
Okay.
Yep. Gotta make sure that's working. Turn it off now. Alright, that was a total pain in the butt right there. That totally sucked. this wire gauge that Lane used for the original expander harness was fine if there was only 4 wires in it, but putting 8 in it made a whole nother ballgame. Too much. Why is that?
Just been messing with it for a minute.
Dude, it takes a while. Yeah, it shouldn't normally, but because of the way I have to implement this, it does.
Okay.
They have like other expansion harnesses you can plug in. There's a whole other CAN bus on this thing. It has 2 CAN buses, and if we had another expansion harness, you could just drill it out or just plugged it in and put another one in there. But I don't have one, so I couldn't do it. So I had to build one. Halfway there. Technically more than halfway, because it was extra hard to do the other stuff because I was doing 2 wires and then 1 plug. But now it's just 1 wire and 1 plug, so that's much easier.
Apparently you don't need reading glasses.
Oh, I do.
Oh.
Yeah.
I can't see shit. That sucks. I mean, I can see far away. Close up.
Yeah. This is the extent. That's fuzzy. That's not fuzzy. That's fuzzy. That's not fuzzy.
And if I ain't got light, I'm really screwed.
Yeah. How old are you?
52.
52. Yeah, I'm 45. I mean, I'm basically 46 or 46 in like a week and a half or something. I don't even know what the date is anymore. It's too long.
So a buddy of mine wants to do twin turbos on a 5.3.
Yeah.
That's something you want to do later.
Yeah, done. I've built them, tuned them, raced them.
Really?
Yep. Should have.
Well, he's got a little 2-wheel drive lowrider he's building right now.
Nice.
He really wants it twin turbo.
Have you seen my Nova?
No.
It's not my Nova. It's my friend's Nova, but I helped build it, design it, tune it. It runs 8s. We compete in a 550 index bracket racing.
I have no idea what that is.
It's drag racing,
Oh,
and so what they do is like the idea is that the cars are as close in speed as they can be, so that it comes down to your reaction time and your consistency. Your ability to prep the car for the different tracks and all that kind of stuff. So the way it works is your car cannot run faster than 5.5 seconds in the 8th mile, which is about 8.5 or so seconds in the quarter. And when you, so then your index is the 550. That's what your index is. That's your speed. And then when you race the person, you can't red light, obviously, and you can't go faster than that. So whoever makes it into the track first from the green without going faster than 550 wins. So it's all about that consistency, the prep, and all of that, and reaction time.
right.
So we built the car. We had never run this series before. We had never actually even done a 550 in the car that we just finished building. We just finished building it. The best time we'd turned so far was a 570 something. And we were in
the 8th of a mile?
In the 8th, yeah. Like I said, which is like 8 seconds in the quarter. And we did a quarter run on it, and we did 8.5 seconds in the quarter with it. But anyways, yes, we go there without ever even running a 550 yet, and entered the race. And before we did our first qualifying run, we had one test pass. We ran a 5:58, I think it was, in the test pass. So I was like, all right, made some changes. And Sean's like, I don't know, man, are we gonna make it? We're gonna make it. I'm like, oh yeah, we got this, baby. So I made some changes. Next run was a 5:53, which is really damn good, right? That time will win races, you know. And then the next one was a 5:52, and then we did a 5:51, and these are all in qualifying. So we ended up qualifying third out of 16 cars, having never even done it before. So that was cool. And then our first race against somebody, we got a bye. So we ran a 5:50, I think it was 5:56 or 5:57. Nothing great. But it was a bye, so we weren't really trying, right? We just wanted to test some new settings and see how it turned out. And could have been better. But then our next opponent showed up, and we spun the freaking tires. Yeah. Spun the tires, ran a 5:55, I think it was, 55. But the other guy ran better, so he got there first and ran a better time. Didn't red light, beat us, so we lost that one. Then the next race, oh shit balls! Where's my other line at? Should we get this right order? Next race, fuck, all three races are basically the same exact story. Qualified at the top, spun the tires. Qualified at the top, spun the tires. Every time, and it was like irritating. But then some old school drag racers that do it all the time approached my driver and said, "Hey, dude, those are the wrong tires." And we started analyzing the data, and sure enough, the tires were being way overpowered, and we were losing a lot of time in just destroying the sidewalls of these things, and they weren't able to handle the power that we put down to them. So we're gonna get new tires, see how it works. But they were right; they were the wrong tires. And the guy that set up the suspension on the car told us they were the wrong tires, and so we knew all that. We just had just bought them anyways, wanted to run them and see how it went. Yeah. And I mean, it wasn't like we were, oh my god, we're gonna win our first event. Like we knew better than that, right? We just wanted the experience. But we did way better in our first event than we ever thought we were gonna do. So it was really cool. It was a big win. It was a good weekend. They had 3 events in one because the other events got rained out. So it was Friday, Saturday, Sunday. So we got 3 events back to back.
What, down to Portland?
Oh, this was in Ohio. Oh. So they just camped there at the track. Everyone camped and partied and got hammered. The first night they got too hammered. Stayed up until like 3 a.m. With like an 8 o'clock driver's meeting, you know, kind of thing. Like, what are you doing?
They do 1/8 of a mile down to Portland.
Do they? 1/8 or quarter? I don't know. I think they do both, right?
Oh, they might, but I don't think so. I think it's all good.
Oh.
Well, at least every one I went to, my brother had a Trans Am. Some super fast Volkswagen, so holy crap.
Yeah, that yellow one.
No, this was like a bug.
Yeah, bug. Yeah.
Oh.
It's not Jim's bug with the yellow stuff on it. Oh, okay.
It had like a rubber car or something. Super fast on the line.
Okay, I need to go get one little piece that goes in the inner here, and then we can plug it in and test it, see if it works. This guy, and a vacuum as well.
You got Venmo?
Huh?
You got Venmo?
Yeah, I got Venmo. No, not Venmo. I got Venmo.
I'll just swing you back to the difference.
PayPal. It's all good. Whatever method is fine. Okay, this is yours. Let's see this guy here. I'll test it in a second. See if we get some thing.
So then I can just unplug it here to mount it into there.
Yep. Yeah, it's pops right there. All right, you're back. Let me go get the little insert for the inside. Leg. I need the insert for that connector. Yeah, isn't there an insert? Back is clamping on me.
Not on. I got boost control set up on Duke's car.
Is it gonna work? Thing?
Yep.
Which car?
This blue one, 3-port on it. That's your tune in between the alley.
Oh, I thought it was the other car. What's the other blue car out there?
That's a clutch.
Oh, okay. Gotcha. Oh yeah, I do want that. I don't know if I did this right.
To the C for you.
Okay, thank you. All right, let's see if it plugs in. Come on, baby. It's in. Shit. Wait, but the O2 just worked. What was going on? How'd the O2 work if it's not hooked up right? No, it's fine. Oh, that's Target. Oh, that's why. Okay. I was looking like that. Watch this move. What is going on? Okay, I can say that. Damn it. Okay. The hard one is backwards. Lane! No. I would- Lane! What are we doing for food? What are we doing for food? I put the fucking pins in upside down. Put the pins in upside down. Damn it. It was a fucking cunt to get in there, too. It's got 8 wires in there. Say what? What? Yeah. It's done being tuned. I'm just hooking the can shit up. Yeah, we can start doing that. It's charging the battery right now. With the charger. Okay. No, it's fine, dude. Sure. Yeah. I can see it. I just need to pull it 'cause it's gonna be tight and stuck and shit. Where's Chase? Lane, where's Chase? Yeah. Oh, okay. It's the one-way strap. Yeah. Cool. That goes. Just one. Where is it? Is it? I think it's in there. 1, 2, 3, no 4. You hide me. 1, 2, 3. Just push that down. You saw me struggle with that earlier, and I gotta put it back up again. Push this on.
You can make an insert that comes out, put them through, and slide it in.
It'd be nice, yeah. I mean, that's what this is supposed to do, but I've got 8 wires in it instead of 4. You know, I'm trying to make this Y adapter here, so that makes it a little more difficult. Usually I just do them one at a time, but I don't have that luxury right now to do all 4. So I have 4 channels here. 1, 2, 3, 4. Get through there. Got it. Okay. Yes.
Yeah.
What? I swear I was grabbing the other one. Just pulled that one too hard. That's close. That was close. That was not. There it is. That's close. Oh, maybe luck. We got it. I think we're good. So, maybe. Looks good. This doesn't. Oh, because this is backwards too now. Okay. That's what I did. I made them backwards on all of them. I went like that. How the fuck did I do that? Oh, I went like this.
Oh, God.
That's right. This is the easy side. Power's on.
Okay.
This way. Yeah. Green on bottom. White on top. Black on top. Red on bottom. Okay. Well, if I didn't blow any fuses, this should be good. Cool. Okay, so it's not getting dead. I gotta change this to. What was that one? What did I set it at? 1 megabit. Okay. Off. Turn off. Can I turn it on? Do it again. I missed my opportunity. I thought it was hold down the middle button. Maybe not. Off. What's this one? There it is. Shift light. Okay. I want shift light. Off. On. Megabit. Yeah. Okay. Now, let's start it. Let's get this. Oh yeah, please. Oh, I guess at the ID. I call it the ID is. One ID 1000. Okay. There we go. She is right there.
Sweet.
So let me go. We can change the screens. Say just AFR, for example. Okay. All these options through here. Just boost.
I don't need that. Why I don't think I do. I have a gauge.
Cool and temp.
That way, if I can have that.
There.
That's it.
Yeah. So then you just click on it if you want to see different stuff.
Oh, sweet.
Like that, and all the screens come up with different information. You can set 12 screens of information on there, so you can just cycle through them.
Okay.
What you want.
So did you set light?
Say what?
Did you set a red light?
For what?
A ship light? Is that what that is?
Yeah, that's for the ship light. Yeah, I didn't set it, but you
Okay.
can set one. Absolutely.
Okay. Well, I got the instructions right here. Right?
You do.
Sweet.
The box they go in. There's a little padded thing for it. Yeah, that gauge is awesome. I love those things. Oh. Yeah, I get the fun part. Getting this thing off.